Hello everyone. Today let's discuss about falling object. By definition 1.3.5, consider a falling object influenced by gravity and air resistance proportional to the velocity of the object. There are two forces acting on the object. The force due to gravity is given by the weight W equal to mg, and the force due to air resistance is minus kV. The net force is F equal to mg minus kV. Now using Newton's second law of motion, we perform a substitution until we get this. Okay. So what forces act on a falling object? When an object falls, like an apple from a tree, two forces acting on it. The first one is gravity. This force is called weight, W equal to mg. The second force is air resistance, where the direction will push upward. So this force opposes motion. It is proportional to the velocity. So air resistance is kV. Okay, the negative sign represents the direction, the negative direction. So the net force becomes mg. The net force is F equal to mg minus kV. Gravity pulls down, air resistance lower it down. Then we apply Newton's second law from physics. F equal to ma, and a is the acceleration. A is dv dt. So we substitute into the force equation. So we get mg minus kv is for F, and then the right hand side m dv dt like this. Rearrange, we move m dv dt to the left. Okay, and then we get this equation. Finally, we divide the entire equation by m. So we obtain first order linear differential equation like this. Example 1.40. A steel ball weighing 1 kg is dropped from 2500 meter with no velocity. As it falls, air resistance is equal to V over 8, where V is the velocity of the ball in meter per second. Find the velocity at time t given g equal to 9.8 meters over second square. So we are given the weight. Weight is 1 kilogram. And then we know that air resistance is given as V over 8. Okay, so that is from the problem. So we extract the important value here. The gravity G is 9.8 meter over second square. And here, look what we have missed. Okay, let's check, read again the equation. A steel ball weighing 1 kilogram, this is 1 kilogram, and it is dropped from a certain height with no velocity. So no velocity means that we get the initial velocity, means that at initial time the velocity is 0. Okay, so here means at t equal to 0, the velocity equal to 0. So number 1, the first step, okay, we want to use the given equation from the previous slide, the first order differential equation, that is the formulation for the falling object. So the equation is dv dt plus k over mg, k over mv equal to g. So let's substitute the parameter value. Mean you have to find what is m, what is k. G is given, right? So the first task, okay, let's find the mass. So we use the formula W equal to mg. So W is the weight is 1 kilogram, and mg is given as 9.8. So your m can be calculated by dividing 1 with 9.8, and this equal to 0.1020. So the next step is to find K. So we find K by using air resistance. Air resistance is given by V over 8. So that means your KV, the formula relates to air resistance, is V over 8. Then we compare here V with V, so means that your K is 1 over 8. So next we substitute into the formula, okay? So what you have here, so after we substitute into this, so you can replace K by 1 over 8 and M by 0.1020, and G is 9.8. Then we simplify this, okay? We simplify this, where we obtain dV dt plus 1 over 8 divided by 0.1020 is 1.2255 V equal to 9.8. So here, this is first order linear differential equation. We have to solve this, and the best technique to solve is by using linear technique, okay? So first, remember the format of linear is dy dx plus pxy equal to qx. So since our problem here is dv dt, but the formula applies dy dx, so you should note that y should be replaced by v and x should be replaced by t. So the format should be replaced as well. So this is dv dt plus ptv equal qt. So first let's identify what is pt. So pt here is the coefficient of v, which is 1.2255, and your qt is the right hand side of this, so it is equal 9.8. So the first step in linear technique is to find integrating factor. Integrating factor is given by the formula of rho x equal exponent like this. So we replace the appropriate variables. Here we are using t. So this is pt dt So this is exponent of 1.2255 dt. So the integration of constant is just 1.2255 d. So that is your integrating factor. Next, let's do the second step, which is multiply the entire equation by rho t. So this is your equation, should be replaced by rho. Okay, so you can copy that, dv dt plus, okay, let's multiply. So let's put the resulting result, which is E 1.2255d dv dt plus 1.2255 E V equals this one. Then the third step is to represent the left hand side here as d dx rho y. So based on our variable, we are using d dt, rho is this, y is v. And then the right hand side. Next, we integrate both sides. So the left hand side, since we have integration with differentiation, so the answer is just what's in the bracket. So it is this one. And the right hand side should be the integration with respect to t. So if we integrate, we obtain this one. Okay, then we want v, so you should divide every term by the exponent, and this number can be calculated together. Okay, you can find the value. And then this part is cancelled, where we divide everything by E. So we divide everything by E. Finally, you will get V equal this value. So this is your general solution. Okay. So next we want to apply the initial condition where we said that at t equal to 0, the velocity is 0. So let's replace the value is equal to 0. So you can obtain C, which is just negative 7.9967. Now you can obtain your particular solution by substituting the value of C. Thus your V equal to this one. Okay, so this is the particular solution, the final solution for this problem.